Dear friends, today we will start with again one of the important type of motion, that is rolling motion. Before start with the actual pure rolling motion, I will revise some basic concept of translational motion. We know that translational motion or the linear motion of an object is along a straight line. The object at rest is brought into motion with the application of a force which is given by mass into acceleration, and the motion takes place in the direction of force. If the object is not applied with any external force and if it is moving with constant velocity v, then the velocity of the center of the mass is v. V is the velocity of the center of mass of this moving object. Object moves along a straight line. In translational motion, the particles of the object perform a translinear motion with same velocity. They travel equal distance in equal time. Every particle travels equal distance. This is the importance of translational motion. In translational motion, all the particle has the same constant velocity. All will move with same constant velocity along a straight line. This is translational motion. What is the importance of translational motion? It moves with constant, all the particles have same velocity. If there is a change of velocity by the application of external force, the acceleration of all the particles will be the same. They are accelerating with the same rate. In a similar manner, if torque is applied on a body and because of that the body begin to rotate, and in the absence of external torque, if the body attains a constant angular velocity omega, then all the particles of that rotating body perform circular motion. All the particles perform circular motion about an axis passing through the center. Here axis is perpendicular to the plane of rotation. All the particles perform circular motion. Here, let the particles of this rotating body has constant angular velocity. You can change the angular velocity. You can change the angular velocity by applying torque on it. The torque applied on it is equal to I alpha, which will give the change of angular velocity. But change of angular velocity of all the particles will be the same. Therefore, angular acceleration of all the particles will be the same. If no external torque, it moves with constant angular velocity. Angular velocity is same. What it means that they trace, every particle will trace equal angle in equal interval of time. This is pure translation in which all the particles travels equal distance in equal time. Therefore, everyone has uniform velocity. All have equal velocity. If external force is applied, they have same acceleration. All the particles will have same acceleration. If there is no external torque and the body is rotating, it will rotate about the given axis. Axis is perpendicular to the plane of rotation, and all the particles will perform circular motion with constant angular velocity. If you apply an external torque, all the particles will change the angular velocity with the same rate. Therefore, angular acceleration of all will be the same. But instead of that, if object is moving in such a way that its center of mass has only translational motion. Center of mass, only translational motion with constant velocity v. And the particles of the remaining particles, let a particle at the top is performing circular motion with angular velocity omega. At the same time, it is moving ahead with the same velocity v. It has both angular velocity omega and the tangential velocity, which is equal to r omega, where capital R is the radius. It has both. In a small interval of time, the particle which is at the top, because of this tangential velocity goes on changing its direction. For A, it will become like this. When it comes here, it will be like this one. When it comes here, it will be like this. This will be the tangential velocity. Every time it is r omega, no doubt. But A point, after some instant of time, come to the B. The center of mass is not rotating, or it is not performing circular motion. It moves ahead only. But the rest of the points, as an example, I had taken here A. A will come to the point B. Let the position of this point P is A. Here position of point P is B. Like that, again it may, position of point P may be the C. After one revolution, again it will come to A. It means that from position S1 to the position S2, the particle P has one revolution and particle displaces back. Particle displaces back a distance which is equal to 2 pi r. Therefore, particle of a body has, this particle is again having angular velocity omega. This particle is also having angular velocity omega. They traces equal angle in equal time. But for this particle, the radius will be different. For this particle, radius will be different. Therefore, the tangential velocities will be the different. And what about center of mass? For center of mass, this tangential velocity r omega, distance from the center for the center of mass is 0. It has 0 tangential velocity. Therefore, it has only translational motion. The particle at the center of mass has only translational motion. But what about the rest of the points? They are moving along the circle at the time, moving ahead, moving along the circle, moving ahead. Now they are moving along the circle with tangential velocity r into omega, and they are moving ahead with linear velocity v. Like this, the combination of the translational motion along with rotation is the rolling motion. Therefore, what rolling motion is? It is translational motion plus rotational motion. Now, if you look little bit more in detail, you will see what are the conditions needed to have a rolling motion of a wheel. For rolling motion, it is needed that the object should be circular in shape. A ring can roll, a disc can roll, a sphere can roll, a cylinder can roll. For that, I will have a very good example of this rolling motion. I got a cylinder here. This is the cylinder. This is cylinder I got. Now, this cylinder. Now, look at this. At the bottom point and the top point of the cylinder. These are the bottom point and the top point of the cylinder. Look at these points. Now, the bottom point and top point of the cylinder are not performing circular motion, only they move ahead. Therefore, all the particles have equal distance displacement in equal time. They have constant linear velocity, and that is only translational velocity. This is translational motion. Instead of that, I got this cylindrical object, and if it is rotating about the given axis, this is rotating about the given axis, neither moving ahead or back. This is pure rotation. Here everyone is performing circular motion about the center. Here center of mass is the center, and the axis passing through center of mass is the axis of rotation. Every particle is performing circular motion about the axis of rotation. This is pure rotation. But instead of that, if the object is moving like this one, it is moving ahead as well as it is rotating at that time. It's a rolling. For rolling, I will do it once again. It is rolling like this one. Object is moving ahead at the same time. It is rotating about the axis. Then we used to say that it's rolling. For rolling, what is needed? For rolling, let us consider this is the flat surface on which the object is rolling. Now, here is the object which is rolling. This is the center of mass. The axis perpendicular to the plane of rotation. And passing through the center is the center of mass. Center of mass has only translational motion. Therefore, every particle in it has a translational velocity v, and it will be same. But particle at the top, let I call this as A, and particle at bottom, I will take it B, and particle at horizontal diameter, I will take it as C. The particle at the top, which is at the distance r from the center of mass, has the tangential velocity in addition to that of this translational velocity. And as the A is performing circular motion with constant angular velocity omega, in addition to this translational velocity, it will have tangential velocity r omega. Similar to that, no, when object come at this point, the tangential velocity is in this direction. When it comes to this point, the tangential velocity will be in this direction. That is along the tangent. When it comes to the B, the tangential velocity will be at this point. And again it is r omega, because it is B is again at a distance r from the center. Now here V, the translational velocity, r omega is the tangential velocity because of circular motion of the particle. Now the total in this case, as V and tangential velocity are in the same direction, it is V plus r omega, and as these two are in opposite direction, it is V minus r omega. And for this I have to plot complete a parallelogram, and this will be the tangential velocity, that is the total velocity. It is under root of V square plus r square omega square. This is the vector addition. Now, to have a pure rolling motion, this V should be equal to r omega, and velocity at the bottom should be equal to 0. For pure rolling motion, the velocity of a particle which is in contact with the flat surface should be equal to 0, and velocity at the top surface should be equal to 2v if v is the velocity of the center of mass. This is one condition. Here also it has tangential velocity like this, and it has linear velocity like this. The resultant of these two will be like this. This is the resultant velocity. And this will be the resultant velocity. The rolling motion is the combination of the translational motion of velocity v, and the tangential velocity or circular motion of tangential velocity r omega at the circumference. For a rolling object, if I take this particle only, it is at a distance r, it has tangential velocity Vd is equal to r into omega. It will be different from the velocity on the circumference r omega. Therefore, particle on the circumference has greater speed of revolution. Therefore, rolling motion is combination of translational motion as well as the rotational motion. Now, we will see how much will be the kinetic energy of the rolling motion. We will derive the kinetic energy of a rolling motion. Kinetic energy is what? It is the energy possessed by an object on account of its motion. The kinetic energy of a rolling motion is equal to, it is the combination of both kinetic energy of translational motion plus kinetic energy of rotational motion. We know kinetic energy of translational motion is half m into v square. Capital M is the mass of the object. V is the translational velocity. It is the velocity of the center of mass, and same will be the translational velocity of all particles of that rolling body plus half of I into omega square, where omega is the angular velocity of the particle of the rotating body. We know that I in terms of a radius of gyration can be written as mk square, where k is the radius of gyration and omega is equal to v divided by r. This is the relation between angular velocity and the tangential velocity. Now, therefore, it will be equal to half of, I should write it as m into v square plus half of mk square. V square is to be, omega square is to be replaced by v square by r square, and it comes out to be equal to half of m into v square in the bracket 1 plus k square divided by r square. This is the kinetic energy of rolling object. The value of k square by r square, it is the ratio of the square of the radius of gyration to the square of the radius of the moving object. It will be different for different object. This will be 1 for ring, and it will be k square by r square will be 1 by 2 for disk. Like that you can find out for different, and like this you were able to get the kinetic energy of a rolling object. Thank you very much.